Okay. Good morning, everyone. Thank you, everyone, for joining the webinar today. And we have it's very glad to have Devin from Overstock to join the webinar talking about the common architecture patterns on Pulsar. And Devin is the senior data engineer at Overstock, and Peng Hui and he wrote a kind of white paper about deep dive into Pulsar architecture for performance tuning. That is also a great write-up for his experience on running Pulsar on production. And thank you, Devin, for joining the webinar. Devin, it's your time.
Yeah, thanks, Shijay, for the introduction. Let's see, so let me go ahead and set up a screen share. Just take a moment here. Okay, I should be able to see a screen with a clear background. Let me get my slideshow started. Okay, can we see that?
Yes.
Okay, great. Okay, thanks everyone for joining. So as Shijay mentioned, I'm Devin Bost. I'm a senior data engineer at Overstock. So we're going to be talking about some real world architectural patterns on Pulsar. And I want to mention that every pattern that I'll be showing here in this presentation has been developed and implemented with the help of my team at Overstock. And there are two types of patterns I'll be talking about. The first is distributed caching for high performance caching. We'll talk about different ways that you can approach that in a few different use cases. And we'll also talk about distributed tracing, which is a use case that I'm really excited about because it gives you clear end-to-end visibility into your pipelines. And since my team has been such an integral part of my experience here at Overstock and in working with Pulsar, I felt that I couldn't do justice if I didn't show a picture of them. So they might be a little horrified that I'm showing this Christmas picture, but I think it's great. And a couple of honorable mentions that couldn't be included in this picture are Stephen Burke, who's in our team in Ireland, and Sam Loon, who's our new product manager. And then also Santa Claus, he's not on our team. So just to clarify, this presentation is not to sell you on Pulsar. It's not to help you recognize if you're not using streaming technology, you're way behind. It's a deep dive into specific architectural patterns. It's fairly dense. And so I'll be available afterwards for questions because we're going to cover a lot of material here. Also, I created this kind of legend slide because I'm referencing a lot of technologies and some of them more than others. So I'll be referring to Jaeger, which is written in Go, hence their creative logo. And this is for distributed tracing. It uses the open tracing standard. And then a couple of other technologies I'll be using a lot or referencing a lot are Apache Ignite and then Apache Flink. Flink is a distributed stateful stream processing engine, and then Apache Ignite is our caching, is used for a caching layer. And then for this presentation, if you see the Pulsar logo, I'm specifically referring to a Pulsar topic, and the blue bounding box is referring to a Pulsar function. You see that in the slides to come. That could also refer to a Pulsar source or Pulsar sink. They're all basically functions. And then the purple box is a Flink job. And let's see, I've got a couple of questions in chat. Let me just see here. Okay. And if people have questions, feel free to reach out. A lot of questions you might ask, I may end up answering during the presentation. So some of those questions I might just address towards the end. Okay, so let's start really simple. Okay, the simplest possible use case would be PubSub, or at least in my opinion. All right, so the idea here, and this is very simplified, you've got some kind of user behavior, and then something happens, and then ultimately impacts the user. Right, it could be the same user, it could be a different user. I think that's the basic idea, right? And it can take different forms. So you could have user behavior that ends up in a web application. You could have it happen the other way around. This could be, maybe take the form of an event, something displays on their screen, maybe they get a text message, lots of different things could happen. And of course, you can chain these together, chain different applications and services together. All right, so that's kind of the simple case behind PubSub. Okay, so now let's go a little bit deeper. Now one possible approach to handling, Pulsar producers and consumers is they can live in Docker containers. You don't have to. I mean, you could run them bare metal, but from our experience, it's a lot simpler, easier to manage and maintain if they're running in Docker. And if they're running in Docker, then you can run them in Kubernetes, which also has a number of benefits. But then you might ask, well, what is this whole pass-through function business? Okay, so the idea behind a pass-through function, I give some credit to my boss, Thor, and he has a lot of experience in the streaming world. This pattern behind the pass-through function, the idea is that it allows us to have separation. We can isolate the security on the producing side, which I refer to here as the ingest path, and from the consuming side, which I refer to as the feed path. And we'll talk about this in a little bit more depth. Because when we have this pass-through function, we can have this separate security isolation. It's also a better separation of concerns. And there are some additional benefits that we get from that. And the performance impact is negligible, maybe a few milliseconds. So for most applications, it's negligible. Let's see, there's a question about hands-on administrative support. So I'll address that a little bit more as we go on, and then I can address that more towards the end. So in this particular slide, and I won't go into details on everything, but this is part of our CI/CD implementation. Let's see, I will mention that Kubernetes does make administration a little bit simpler, but again, we can talk about that question in more depth later. So in this case, we have, as part of this this implementation, the ingest path, we issue a token, for the producer side, and then we have this feed path on the consumer side. And then there are a number of things that we can build into this. I also want to point out that this idea of taps, which we'll talk about more later, which is really important for tracing. And so that occurs in a couple places, and you can also tie in other things like validation. Again, talking in depth about CI/CD, that's for a whole nother slide. So that's out of the scope of this presentation. Now in the real world, you're typically never going to want, for a production case, you're typically never going to want to have a single producing container or pod and a single consumer, because you want higher availability. And especially if you're running in Kubernetes, you really want the benefits, of leveraging multiple containers to get that availability. And that's super easy to do. So, if you're running Kubernetes, you can easily multiply the number of pods with your containers. And basically the architecture is the same. Now let's talk about caching, right? So that's one of the things I promised in this presentation. Some of you may recognize this as the logo for Redis. So that brings up the question, well, is this a safe approach? Well, is Redis designed for distributed applications or for these kinds of implementations? Well, absolutely not. Redis is intended, Redis is not intended for this kind of use case. It's not distributed, it doesn't have persistence. And so if Redis instance goes down, you lose all your data, and it can cause major problems. Okay, so it's much safer to use a distributed cache technology like Apache Ignite. Apache Ignite, it's a newer technology, and it does support the Redis protocol, but the Ignite protocol itself is actually faster. And so if you're aware of the microsecond kind of performance that you get from Redis, to think that Ignite is even faster is really a big claim, but there's good data that shows that it is, and we've noticed in our experience that it's faster in most use cases. Ignite also has a number of benefits. First of all, it's distributed. It does use Zookeeper, like Pulsar, so you can use the same Zookeeper cluster if you desire. It also has smart persistence that's configurable. There are different ways that you can persist that data, and it's fairly clever in how it does that. It's faster than Redis, as I mentioned, at least for most use cases. And if you construct your backing cache as a table, which I strongly recommend, then you get the same cache that provides the various features I mentioned, but you also get some additional benefits, such as simple SQL operations that that allow you to get better visibility. Now, someone made the comment that Redis does persist data if you want it to. So maybe there are some ways that Redis can do that. But again, it's unless they've made some major infrastructure changes or architectural changes, it's not a distributed technology. So again, I strongly recommend using Apache Ignite. Ignite also has a new feature that supports transactions. And so it can be nice to get transactional support. Now, what if you have a business critical service where you can't lose messages? Now, some of you might be wondering, well, but doesn't Pulsar already guarantee that messages won't be lost? You might be thinking, if Pulsar guarantees that messages won't be lost, then why would we need to address this? Well, there's a difference between Pulsar losing messages and your application losing messages. There are a lot of things that can cause applications to lose messages downstream. It may be things totally out of your control. Maybe you've got other people who are consuming data from your service, and there's somebody ships a production bug. There are a lot of different reasons why you might want to be able to utilize a backfill path, which is what we'll introduce. So we take that same pattern, that we saw on the left with the pass-through function, and we're introducing a replication function. And what we're doing is we're replicating data. In this case, we're taking from the feeds topic, and we're replicating it to a persistent storage. Now you can notice that I didn't put a SQL database on this list, and the reason is because for this kind of thing, SQL is not necessary, and the transactional guarantees of SQL may be inappropriate. I've seen a lot of people design workflows and applications that really terribly abuse SQL databases. And so my point here is it's really important that you choose the right storage technology for the right job. I've also seen cases where people have used where they needed transactional guarantees and they used the wrong technology, and that can create even bigger problems, but I won't get into those kinds of things. So the point is use the right storage technology. Now, in this case, what we're really doing, in a sense, is combining Lambda and Kappa architectures, right? So the idea behind Lambda architecture is you've got a fast path and a slow path, right? Your slow path is kind of your bulk path, and definitely not the real-time case, but the hot path is supposed to be, for more of the real-time stuff. And now with Kappa, everything is streaming, right? Everything, you could say, everything is leaning more towards real-time or maybe near real-time. But the idea is you never have a slow path. Now this sort of combines both those approaches, because what we're doing is we're leveraging streaming for basically everything except for this additional persistent storage, but we're loading everything into our streaming architecture. So the idea here is when you need to run a backfill, you can run your batch job, and you could also use Apache Flink if you wanted to. For bulk processing, Spark or NiFi, you might get a little bit better performance, but Flink is certainly good technology for these kinds of things. You just might not need a lot of the additional guarantees that Flink offers that are really more designed for streaming use case, such as checkpointing and things like that, at least for this implementation. But the idea is that you load that data into your backfill topic, and then it can flow downstream. Now, if you have something that's hitting your end users, you have to be very careful to make sure your service is idempotent, because otherwise they're going to get duplicate messages, and that can cause other problems. And so one way to address this is to use persistent caching, or this idea of distributed cache like Ignite. So you can just check if the messages have been delivered, and there are different ways that you could instrument this. It doesn't have to be at exactly this layer. Maybe you put it higher up, but you just have to be careful about race conditions and things like that. We'll talk more about race conditions later in this presentation, because when you deal with parallelism and streaming applications, there you have a lot more opportunity for race conditions, since everything's basically asynchronous. So we'll talk about that more. Now, there are a lot of moving parts in this slide. And so some of you might be thinking, well, shoot, this is a lot of stuff. It seems like a lot of work to implement. So can we simplify it? Well, yes. And we'll simplify it in steps. So one step that we could do is we could replace that, that layer of consumers running in Kubernetes with Pulsar Function. And Pulsar Functions, I'm not going to go into too much depth in what they can do, but one thing I want to mention is you can very easily parallelize your Pulsar Functions. It basically is just a config parameter, so you can very easily, scale it, as many times as you want, as long as you have enough memory in your brokers. Now, in this case, what we're doing is we're bulk loading. We're pulling from our feeds topic, and basically the architecture is exactly the same. Now we're going to cover a couple of different architectures or patterns in the next few slides. And so I want to mention here that if you want better isolation, so in this case we're pulling from the feeds topic. If you want better isolation, you could potentially add another pass-through function. So you're pulling from an intermediate topic instead, so that you can keep the ingests and the feeds topics nice and clean and isolated from other applications or use cases. Okay, so now we talked here, we're talking about these are things that are going to hit end user, right? We talked about the idempotent aspect of deduplication, things like that. What if we're just trying to put that data into a cache and make sure that we address the backfill case? All right, so here's option one. In this case, what we're doing is we're pulling from the ingest topic, and then we're bulk loading into our feeds topic. And again, this is where we have to be mindful of possible implications because we don't have that layer of abstraction, and so if you had to make certain changes in different places, you could end up with it could make migration a little more complicated, or it depends on your implementation, but we've seen a lot of benefits from having the additional layer of abstraction by using these pass-through functions. But otherwise, the application or the pattern is basically the same. The operator can start the batch job when necessary, and potentially, you could add some automation. Maybe if you have some analytics downstream that detects that you need to run a backfill, you could definitely add some intelligence there. Let's see, a question came in. Is replication a Pulsar function? Yes. So in this case, yeah, anything with the blue bounding box is a Pulsar function. And so that's what we're referring to here. We'll talk about a Pulsar replication. Well, actually, we won't really talk about Pulsar replication in this presentation. We'll talk about retention a little bit. But yeah, dealing with geo-replication, things like that, there are different strategies, and that's really kind of out of the scope of this presentation. Okay, so let's look at option two here. In this case, this pattern, what we're doing is we're separating, we're creating a separate topic for a backfill path for the feed side. Well, actually, technically it wouldn't be the feed side. It's kind of a separate thing because feeds is really intended for this kind of PubSub pipeline here. So we have a separate piece that, specifically for backfill that's loading into our cache. And one benefit of doing this, of having this separation, is you get better quality service. You can control how this, you have separate control and separate visibility into these two different pipelines. So that way you can ensure, let's say, if you need to make sure that that the data that's still coming in real time makes it into your cache as quickly as possible, and you're not slowing that down. You could do things like you could potentially apply rate limiting, and there are other things that you can do to make sure that that you're not interfering with this real-time path. And so also the metrics and visibility, like in Prometheus, if you're using that for your metrics, you can much more easily see what's going on in the two different paths. So this makes things a little bit cleaner. And then option three is where you're using Pulsar's retention. Now, if you use retention, especially in a high velocity topic, something you have to be very careful about is making sure that your bookkeeper cluster can keep up with your brokers. Because if your bookkeepers can't keep up, if they can't persist data as quickly as the brokers are ingesting it, then what's going to happen is that the brokers are going to end up with memory problems. They're going to, the memory is going to fill up because bookkeeper can't offload that data fast enough. So be mindful of that. Bookkeeper needs fast storage, and talking about how to optimize bookkeeper is out of the scope of this presentation. But if you use Pulsar retention, then you can tier your storage. in a cloud storage like Google Cloud Storage or S3. There are different strategies around doing that, and then you could have additional techniques about how to archive that data, or how deal with that in the cloud side. But the idea here is that you have two separate functions that are consuming from a topic. It could be your feeds topic, it could be something downstream. But the idea is that if you use the exclusive subscription mode, then each one of these functions will get its own subscription, and so you can still have the fast path here. And then this backfill piece, basically, you keep this function stopped until you need to run a backfill, and then when you need to run the backfill, you just start the function, and it will pull all that data that's being retained. And you can set retention to be forever, or you could have it, with a certain time span. You have different control over that. It depends on your application. So for example, if you only need to sort data for 24 hours, because after 24 hours, it's not going to impact your customer for whatever reason, then you don't need to retain it forever. Now, if you're using that data for analytics, that's a whole separate thing, but then you need to ask yourself if you're using the right storage technology to make analytics easy. Let's see, and then dealing with replication, yeah, again, that's kind of out of scope here. Okay, so now let's say we want to add caching to an application that's a little more legacy. So this is one potential pattern that we could apply, where let's say we can't touch this, the code for the website. Maybe it's managed by a different department and there's some red tape there. We could use Apache Flume to pull those logs. And if they have raw click data, then we basically have everything we need, assuming that the data that we want is actually in these logs. And so you could then filter that down to what you're, to the desired clicks you're looking for. Extract, since it might have a lot of data in there, you're probably going to need to extract exactly what you're looking for, and then you can enrich it if necessary. And you could feed that back into the website. Although if you're pulling that data back into the website, then again, that might require touching the code. So that's something that would have to be addressed. Although I guess technically you could have the website pull directly from Ignite, but again, those are implementation details, and I always recommend making sure that you have, utilize Pulsar as much as you can to make things real time. Sometimes it's hard for people to break bad habits or old habits and really think from a streaming paradigm. So that can require, a mindset change. Also, in this case, I just want to clarify that I'm omitting some of the details, with the pass-through piece, just to keep this slide a little simpler. Let's see, I think that's about it for this slide. Okay, so now a better approach, instead of, having an intermediate piece, is to just hit Pulsar directly. It does require, making some changes to the website code in terms of how you're writing your data. But you're going to get better latencies, and you also have more control. In this pattern, though, you're still going to have a lot of data. It's going to be a little bit messy, right? You're going to get a lot of data that you probably don't really care about, at least, for this particular pipeline. And so you're going to have to filter a lot, and it just might not be necessary. A cleaner approach is, that gives you better separation concerns, is to have specific purposeful topics, right? Where you're writing very specific data that's thought through from the perspective of how is this data ultimately going to be used, and making sure you instrument it with the end in mind. If that data is ultimately going to be used for machine learning or analytics, then you really have to think carefully about what data you're including, because it's really easy to, to ruin your analytics downstream if you're, for example, missing certain IDs that, make it hard to join or things like that. So be mindful of what data you need, and make sure you're getting input and feedback from the people who are ultimately going to be using that data. Now, what if you're using a graph engine, right? You've got a more complex query, but you need to make sure that data can be available in real time. So what we're doing here is we're separating the caching layer from more the transaction processing layer. In this case, we're using dgraph, which is ACID compliant. But because in this case, what we're doing is we're taking deltas, right? So that could be state changes, or incremental changes. Now, if it's state change, that could be like turning something on or off. But if we're only writing partial records here, and there may be various reasons for doing that, but then we need to query the entire record. Well, we have to be very careful that we don't end up with race conditions. So we're going to talk about a synchronous pattern. Typically when we're talking about Pulsar, we're talking about asynchronous approaches, but there may be cases where you want a synchronous approach. So we're going to talk about how to do that. And so kind of in a nutshell, the idea is that, you write the change, but you wait to make sure that it succeeded. And you may need some retry logic in case a transaction failed. And then you can return the success state, and potentially with some data downstream that we could then use to get the full record. Now, depending on the data flow and what you're dealing with, you could potentially end up with a race condition here as well. So you just have to watch out for that. But I'll show you the way that you handle that is basically by consolidating your logic. So now let's talk about okay, so if you need robust verification, you want to make sure your deltas are in order, aren't duplicates. Let's say, somebody, because messages get out of order, you want to make sure that if something, let's say it's an IoT kind of use case and something, you got a signal that something should be off and then on again and then off. You want to make sure that if it's supposed to be, if you're getting data that says the application is off, it's supposed to be off. You don't want it off when it's not supposed to, right? And of course, it's just one example. Now, kind of the first thought could be, well, why don't we just put, a filter on here, that kind of a gatekeeper that will check if messages are already duplicate or late, and then handle those, right? So that, that might seem like a good way to separate concerns, but we have to be mindful of what happens when you turn up parallelism, okay? So lots going on here, right? When you turn up parallelism, you have to remember you've got latencies in between all these different things. And there are lots of places in this case where you could end up with race conditions. So you always have to be very careful to design your applications in a way that will not cause race conditions, especially when you're dealing with synchronous processes, since they're a lot more sensitive to those kinds of issues. So what you want to do is consolidate your logic. Now, typically, for a lot of asynchronous applications, you want to keep things nicely separated. But when you have to worry about race conditions and deal with synchronous kinds of operations or leverage transactional guarantees of the database, then there may be cases where you want to consolidate your logic more. And so in this case, we could check, we could leverage dgraph specifically, or I guess you could use a SQL database here. Just make sure if you do that, that it's the appropriate storage technology for you to use. You can check if if your data is duplicate or outdated, and then if not, you could write the change, waits for success, and then once it succeeds, you could return. And then in a Pulsar function, when you return, what that means is you're sending a message downstream, and then in that case, you're getting the full record. And again, you have to be depending on the data flow and what you're looking at, there may be cases where you need to add this piece as well into the same function just to prevent other race conditions. But it does work. So then, assuming that there aren't race conditions from this, from this particular approach, of getting the full record from this update, when you scale out one, then you're going to avoid those kinds of problems. So just be mindful of that. And then again, you may need to implement, transaction specific kind of logic like retrying to make sure you're adequately, you're not losing messages. Also, you need to be mindful about what your data contract upstream looks like. So, and this may be obvious for some of you, but if you need to make sure that things are ordered correctly, well, you need to make sure you have timestamps. Always be thinking about the data contracts and how that's going to affect downstream applications. Now, what happens when you have a large or complex function flow? Right? How do you debug it? Okay, let's take an example like this. All right, a lot of things are going on here. We've got data coming from Kafka and different places. We've got older web applications, some newer ones. We've got high velocity services that are pulling data from Prometheus and using HBase. HBase is designed for very, very large tables. We've got data that's ending up in BigQuery for analysis. We've got data that's ending up in Druid for, for BI, dashboards and things like that, and for exploration. We've got data that's going into dgraph that's being used for a near-time enrichment case. And then ultimately all this data is getting pre-processed and then pumped into Elasticsearch to make a very high-performant and flexible kind of solution for web application. Now, how do you troubleshoot this, right? How do you debug it? What happens if you've got messages that aren't reaching their destination? What happens if you've got a message that's getting transformed incorrectly, you're seeing null values, and what the message looks like maybe up here, right, or here, but then, and then you see the results down here. Well, how do you figure out what's going on? This can get even more tricky when we recognize that this could be a multi-tenant application, right? So you could have different teams that are responsible for different pieces of this. And so, you can't necessarily modify their function code, or I guess you could, try and impose yourself, but we'd like to see if there's a better way to do it. And then the same kind of issue applies with data contracts. Right? Do you really want to have to, force everybody to use a specific kind of envelope? It may be, maybe a long time ago with SOAP protocols, that was kind of the way to do things, but it slows down development a ton, and it's going to make it harder for people to get started because, if there are all these additional requirements just to be able to pump messages through the pipeline, then it's going to discourage people, and they're going to want to try to do easier things and take shortcuts that maybe will cause other issues long term. So let's look at this kind of from a sideways perspective. All right, so the side view is we've got different topics, and let's say you've got a message coming through, it passes through the function, and then some unexpected transformation happens, and then that continues passing on. And maybe this is where we end up with a null value or something. So how do we deal with this? Okay, now we'll talk more about the open tracing standard in a little bit. But this is the idea of what we can do with this with distributed tracing architecture. We can chain using a pattern that I'll demonstrate. We can pair these messages together into what open tracing calls spans. So basically, a span in the open tracing context is something we'll emit it to Jaeger, and it contains certain information. And then we can wrap all these spans into a single trace. So it looks kind of like this, right? And here's that Jaeger logo. By the way, if you want to learn more about using Jaeger in the open tracing standard, there's a great book called Mastering Distributed Tracing that I encourage you to check out. So you've got a trace at the top, and then you've got a spans, and spans can also have spans as children. You can have that n number, I think, or maybe there's some limit, but it seems it's pretty deep if I remember. And then spans, their leaves are going to be comprised of tags and logs. And the only difference between a tag and a log is a log has a timestamp. So in our message case, most of what we're going to be doing is dealing with tags because the messages already have timestamps. And so I'll show you how we do that. And since, I assume that a lot of you are familiar with RESTful case, this is kind of what this looks like, just as an example, because I think it's, a lot of us are familiar with web applications, and this is an easy way to see what you could do potentially with distributed tracing, and then we'll get back to the Pulsar side. So in this case, you could see like you've got a SQL select query. It's long running, taking 1.65 seconds, right? Probably needs some indexing. But the idea is, so this is the Jaeger dashboard. You can see the entire trace spanned 2.11 seconds. And you can also see other details, right? You've got a parent span, and then you've got child spans that drill down. And then you can see if there are other issues involved. And then you can see tags, and then they have logs and other things. We don't have to go too deep here because it's just an example. Now dgraph, if you use dgraph as a graph database, dgraph has support for open tracing and Jaeger built in. And so when you enable it, you can see query execution plans in dgraph. And so this is what that looks like. And so you can see a similar kind of breakdown of, of all the different pieces and how much time each piece comprises the entire transaction. And then if I were to click on these children, then you could see additional details, with logs and and tags. So you could get additional information about specifically what was going on with that particular part of the transaction. And then before we connect a few pieces here, I want to just explain a piece about how Flink operates. For those of you who are unfamiliar with Flink, Flink is a stateful stream processing engine. You could think of it as like a pure stream approach to Spark. We have a lot of control over the kinds of windowing that we can do. Flink is fairly sophisticated in that way. And then we can leverage its stateful capability to do streaming aggregations. And so a lot of these operations happen in what's called a keyed stream. And so in this case, a very simple representation would be you could count by key. And so, in this case, the color represents a key, but that key could also be, a product ID or a user ID. And if you need to store a lot of state, then you can use RocksDB as your backend for Flink. RocksDB is also currently used by the current version of Apache Bookkeeper, which is used by Pulsar for storage. It's very fast. But you don't have to use RocksDB if you want to just keep that state in memory. And I won't get into too much depth there. But the idea here is you got a window. So let's say a session-based window. One thing that's cool about a session-based window is you can have your windows separated by key. And so let's say we're keying by user ID, and you see that the user hasn't submitted any new messages over some period of time that you specified. Then you can close that window and then run the aggregation, and then it continues downstream. Whoops. So what we're going to do here in this pattern is we're going to combine Pulsar and Flink and Jaeger, and then Jaeger can use Cassandra or Elasticsearch as a backend. And if you're using Elasticsearch as a backend, then you might there are some additional things that you could potentially do if you want to do analytics and things on it. I won't get into any of that in this presentation. Okay, so there's a lot going on in this slide. So we're going to break it into pieces and go over them. But recognize, so a lot of the essential part of this flow is the behavior of the tap function, and then we'll talk about how the rest of this works. So the tap function, and I mentioned this earlier in the presentation just briefly, basically what it's doing is it's tapping a topic, but it's adding certain metadata that's really important for tracing. And it could be also useful for validation and other things. So the idea is we're grabbing the message, we're attaching metadata. Some of the metadata is easily available, such as the name of the tenant and the namespace, and you can add a timestamp for when you receive the message. But this other piece is this correlation ID, and this is derived. So we'll talk about how that works. So basically, in the config for the tap function that you specify, you provide this correlation key, and this is the key that you're going to use to inspect the message and get this correlation ID that you're going to use to chain messages together. So there is an assumption here that in a particular function flow or a particular message flow, that there is going to be some value on your message that will remain on that message for the duration of that flow, that will allow you to associate each phase of that or each step of that message as part of the same trace. So there may be use cases where that breaks down, such as if you have aggregations, but let's consider the fact that if you're running a big aggregation on a bunch of messages, well, then tracing that single message doesn't really totally make sense in the same kind of context because it's getting sucked into the aggregation. Now, I guess there may be some creative ways that you could stick that message in there somehow, and so you could tie the aggregation to the message, but that's going to be out of the scope of this presentation. But the idea here is it's inspecting the message and then creating this correlation ID. The reason that we append the key to the value is to prevent collisions, because potentially you could have a user ID that has the same number as the product ID, and you don't want to confuse that. Okay, so then downstream, right? So we're looking at each tap is going into a different topic, and then downstream we've got this Flink job that's joining these together. So it's listening on these topics, or potentially, I guess you could join them in other ways. But the idea is that your Flink job is looking for this correlation ID, and it's joining the message streams based on that. And then after it joins them, it and completes the window based on the key, which again could be session based or based on some other kind of approach. It then passes that downstream. And then we have the sampler, which for dev use cases where you're sending test messages to the pipeline, you're probably going to want your sampler to not filter anything out. So it would just be kind of a pass through that point. But in production, if you're capturing 100% of messages passing through your pipeline, you're going to get a lot of storage volume that you're going to have to deal with, especially if you have a lot of high velocity topics. Also, it's going to be biased towards so let's say you're sampling 1% of messages. Well, it's going to be biased in favor of high velocity topics. And so there might be cases where you want to turn down the sampling, to maybe 1/100% for a very high volume topic or high velocity topic. And then for other topics, maybe you want to, capture, 1 or maybe up to 10%. It just sort of depends on your use case. So the sampler function, could be simple or it could be more complex depending on your requirements. And also that's, this is a Pulsar function, right? And then the Jaeger sync. So this, and I guess you could put it in a function, but a sync is what we use. The idea here is you're taking those payloads that you're getting ultimately from, that Flink is constructing, and then you're building a span tree. And it's fairly flat, right? So you've got a parent span, and this all ends up in a trace. So you've got a parent span that has a correlation ID. And then all the children represent each tuple or each pair of messages. And this just allows, it's a little bit verbose, but it allows us to have a nice clean way of representing that. And then one thing that's really nice is when we have the start timestamp and the end timestamp, then we can get accurate measures in the Jaeger UI for what this looks like. And then Jaeger, will store that again, either Cassandra or Elasticsearch in prod. You don't have to do that, but if you, for most production use cases, you're probably going to want a backing storage like that. So this is what it looks like, and I redacted a little bit of information here. And the duration looks kind of goofy. This is an old picture that I took. In this case, what we did is in our dev use case, we artificially constructed, or we synthesized messages, and the date timestamps in the messages were large, and so that's why you see a really large duration, because it's actually looking at the differences between the timestamps in the first and the second message. And again, if you're interested in learning more about Jaeger, please look into it further. Also, it'll capture every value that you have available. So if some things are omitted, maybe your tap isn't capturing what you're expecting, it'll, at least in our implementation, it just converts those to strings. And sometimes it's not really a big deal because you have topics that also have that information, but I'm a big fan of adding, additional information that might be helpful for analysis. Because if it requires a developer to have to convert a field or make things cleaner for analysis, then it's not going to be. It's better to do that in a pre-processing or upstream kind of context, at least in my opinion. And I'm sure that any of your analysts will agree with that. And so, like for example, a timestamp, you can convert that into a form that makes it easier to do different computations. But if you do that, make sure you do it correctly so that you don't end up, with different values. Okay, so do we have questions? I'm sure somebody's got a question. I guess you can just put it in the chat and then I can answer it if that's the best way. I don't know if there's a way for me to open up microphones. Okay, let's see here, more Q&A. Let's see, Q&A. Open. Is there a Pulsar to Druid sync? I believe that there is, somebody started working on it. I'm not sure what at least in the open source world, we ended up going kind of a roundabout way to get our implementation working. One thing that's nice about Stream Technologies is you can often chain them together. So you might be able to get to Google PubSub, and then you might be able to get to Kafka or something, and then finally into Druid. So there are some different, you might have to be creative there. And then somebody asked if I could share a code sample of Pulsar plus Flink and Jaeger. I personally am of the opinion that I'd like Overstock to open source a lot of this. I do need to get permission before I do that, but that's something that I'm actively working on. I've actually been working on that for a number of months. We just need to get an executive sponsor to let us do that. And once we can do that, I'd like to open source a lot of what we're working on. So that's something that's in progress. Let's see, a few more questions. You talk about some interesting issues you were able to resolve using this tracing approach. So the tracing stuff, we're currently, let's see. So we're currently not running that in production yet. It's still fairly new. And we noticed that in our case, the version of Pulsar that we're running did not have good support for Flink. So we had to upgrade that. And then there are some other things that we ran into. So we haven't yet upgraded that to run it in production. Some examples though, that I could give of where this would be useful. We've had cases where bugs have hit production, and it's taken, let me see if I can go back to a particular slide here. Let's see here. Let's talk about this. We'll go to kind of a big flow. So let's say you've got a message that comes in, and you see the output. Maybe you're looking and you're doing some exploration in Druid. Maybe you end up with something in a dashboard that doesn't quite look right. So you're looking around in Druid and trying to figure out what's going on. And then you notice that the data that you're expecting is not the way it looks. Well, at that point, how do you figure out where that failed? So what you could do is you could try and, if you can figure out maybe what the source message was, then you could try and run unit tests for each of your functions. And that's pretty time consuming, just try and, especially if you have to deal with different teams or other people who develop them, you got to get them all together and, run them, set up a unit test for each of them. And then maybe it turns out that you run these unit tests and then it turns out that, that you're looking at the wrong message. And it was totally a different message that ended up here, but you couldn't tell because the message was malformed. So this is an example of where, you could easily pump messages, from the starting point through your tracing architecture and just see the whole thing in one shot. And so it gives you a really nice way to visualize all the different steps or all the different transformations that happened. Let's see, you're expecting us to learn all these different technologies to participate in your ecosystem. It sounds like this was from someone Overstock. Hi, Pete. Well, it depends on what you want to utilize. You're not going to have to build tracing flows if you're just using our platform. But if you want to be able to use the Jaeger UI to see traces, well, you're going to have to at least learn how to use the UI. If you want to utilize Ignite, there are different ways. You could write functions that interact with Ignite. There are different ways of doing that. So it just sort of depends. And you're welcome to reach out to me later and we can talk about that in more depth. Let's see, is there a common pattern for implementing priority queues with Pulsar? Let's see, maybe if I could get some additional clarification about that, that would be helpful, like priority queues. We talked about like quality service for different pipelines, but it sounds like you're referring to something more specific. So it'd be helpful if I could get some more context around that. Let's see, do you use HDFS for long-term storage? I guess I can click on these as answering live. Okay, done. Let's see, we've got a bunch of questions here. Do we use HDFS as long-term storage? And can Spark read that data? Yeah, so we have analytics folks at Overstock that are using HDFS for analytics, and they have Spark developers as well. And so, yeah, there are cases like, and that's why in this slide I showed a use case where that data is getting written to HDFS. Now you could use a sync instead of a function for that. So that's one way you could approach that. Any tips on designing Pulsar functions, preloading, async versus sync? Let's see, that's a pretty big question. So I could take a note of that as something that, that we could address in a whole nother presentation. because there are a lot of different approaches. I mean, you can use Pulsar functions for pretty much anything. So I did talk a little bit about async versus sync and anti-patterns. I talked about race conditions, but there's definitely, I could go more into depth of that in another presentation if there's enough interest there. Let's see, will support for Kafka protocol in Pulsar solve the problem since Druid supports Kafka? Potentially. I'm not an expert on Kafka protocol running on Pulsar. For that, I think Shijay is probably your expert. So in that case, you could reach out to me afterwards and I could get you connected with him and we could find out if that will address the problem. Let's see. Have you connected or plan to connect Pulsar to a service mesh via gRPC? That's a great question. That's something, if you could reach out to me after, let me make sure my contact information is easy to find. Let's see here, right here. So please feel free to send me an email or you can send me a tweet or reach out to me on LinkedIn. I'd love to talk about that more further. We haven't, I mean, it's not currently planned, but I'd like to learn more about what you have in mind there. Okay, how scalable are these functions? What language do you use? Scala or Python? Scalability is different. Okay, so the scalability functions scale pretty well. Since they do run in the JVM, they do require their own memory. So they're not, they're not the lightest weight of things, but you have to make sure your brokers have enough memory to support them when you add parallelism. So if you have a lot of really function-heavy workloads, then that's something you have to be mindful of. What language do you use? You can use basically any language that runs in JVM. And Thor, my boss, I mentioned, he's experimented with that, and he's found that anything that can run in a JVM, you can run in a Pulsar function. He was even able to get Ruby to run in that environment. We have some folks that have used Scala. Now for native support, Pulsar does support Python functions. And then I've actually contributed a little bit to the Go function side. That work there's still a little bit more work that needs to be done on the Go side, but it's making good progress. Let's see, what other technologies did you evaluate before choosing Pulsar? Why did you choose Pulsar? This question is really kind of outside the scope of this presentation. I have another video that I could refer you to if you reach out to me. And then there's another one that I'm getting ready to publish that addresses that as well. But we looked at, we've used Kafka, RabbitMQ. There are a number of, there are actually a lot of technologies. And so again, that's kind of outside the scope of this presentation. Have you tried using Pulsar functions with AWS Lambdas? We haven't done that. There's some trick that would, that would be involved to do that. But you can think of a Pulsar function as like a Lambda function. Somebody asked GJ if you could, can you share StreamNative Slack link?
Yeah, can you reach out to me and I can answer those questions. Yeah.
Okay, all right, thanks for chiming in. Let's see, is WebSocket API a good choice for .NET Core applications? Ooh, that's a good question. I actually have not yet, it's kind of funny, I have a lot of background in working with .NET, but I have not yet used .NET Core with Pulsar. Yeah, Shijay, do you have a comment?
Yeah, so there are currently two .NET client available. That one is in Pulsar. The other one is the F# client. I think either one, a bunch of the applications or service or companies are using those two libraries. So you can use those two libraries for your .NET core applications. And if for simplicity, you can go for WebSocket API.
Okay, yeah, thanks for answering that. Let's see. Then Tim asked about span trees a little more. Take it to be a tree over nodes that are spans, where a span is an arbitrary subset of topics. How is hierarchy determined? How are you choosing topic subsets? Is the tree structure likely to be complex? It really depends on how you set it up. So let me go back to that slide. Let's see. This one here. Span trees are actually basically, it's a very simple concept. It's easy to, think too far into it. So basically you can, it's all how you actually have to construct the span objects. And if you want a span to be a child of another one, you have to, you actually have to put that in there when you construct the spans. But the, the very, the leaves are just tags or logs, right? They're just key value pairs. And so let's see here. Let me go back to, right. So in this case, we're putting messages in there, but you're not required to do that. This is something that we invented, this idea of putting Pulsar messages into these spans. And so you can see like we've got the first message. In this case, this is just one, this is, if I could scroll down here in this page, and then you would see the first message and then the second message. And you can see these are just, let's see, I think actually these ended up showing up as logs. So I think this is an earlier picture. But the idea is these are the key value pairs that are part of that span. And then there's kind of an inside joke about how we ended up coming with this name Splinkler. So I won't get into that. Part of that was we're combining the names of Flink, Pulsar, or creating a span, right, which is spanner, and then Jaeger. Anyway, so that was kind of the idea of the child. And then in our particular implementation here, it stayed flat. If you wanted to, you could probably get creative and create a deeper hierarchy, but for our purposes, it was very flat. If you have more questions about that, please feel free to reach out to me. When will official Pulsar Flink IO be coming? Actually, there has been some work done on the Flink side to get Pulsar support to be more official. CJ, maybe you could comment on that.
Yeah. So in Pulsar main repo, there's we maintain a kind of a simple implementation of Pulsar Flink connector, and that one is going to be deprecated in future releases. And we have a more comprehensive implementation that basically cover the schema integration and also state integration, as well as the exactly one support. And that one is the one is contributing to upstream Flink. And there's a Flip. Flip is a Flink improvement proposal. And that is Flip 72 is tracking the progress of adding official Pulsar support in upstream Flink. And so it should be coming out soon. Yeah.
Awesome. Thanks for answering that. Let's see. And then the last question, when is Beam IO of Pulsar coming? CJ, do you know?
Yeah, so I think the Pulsar community didn't go directly develop the Beam IO, but there was an issue in Beam project that there was one or two developers in Beam community is developing a connector for Pulsar. You can there's a GitHub issue in Pulsar side to track that progress, and there's also a Jira in Beam project. So feel free to use any of the issue or Jira tickets for tracking the progress.
Awesome, thanks for addressing that. And it looks like that's all the question. Okay, so let me go back to this question that Matt Lund asked earlier. It says at some point maybe address how much hands-on administration has been necessary to support production otherwise by cloud and dev operations. So I will say this is something where one of the reasons why I've been wanting to open source some of what we've been working on Overstock is to address the CI/CD case and to add automation. The way that we've approached this is Pulsar has a RESTful endpoint that you can hit to deploy different things. There's actually, I mean, I could give a whole nother presentation on kind of, how we addressed CI/CD starting from the beginning of when we first started using Pulsar, and then how that evolved. Let's see, I guess I could go back to one of the earlier slides here. It's like one of the first slides. Sorry, it takes a sec. There we go. The idea behind provisioning, like we went through, started from trying to use the, Pulsar on the command line, and then writing a shell script for that, and then writing a Python script, and then that turned into using the Java Pulsar API, and then eventually we rewrote that into a Go service, a Go Pulsar Producer that listens to a Pulsar topic that specifies exactly the payload for the config. And I thought about putting a slide in here with that information, and I ended up omitting that. But I could, if there's enough interest, I could give another presentation and talk about just the CI/CD use case, because we've done a lot of work around that. Also, we have a UI that we've built for visualizing Pulsar flows. That I also ended up omitting for the same reason from the presentation. But that UI allows us to visualize everything that we've deployed and how everything is connected. And so that actually gives us a visual representation that's not too different from that big, let's see, the big slide here. Where is it? See if I can pull it up on my side. This one, where we can actually visualize like how things are flowing, what they're connected to, and then we can see like what latencies look like, what backlogs look like, and that was developed by Kathy on our team. She's done a lot of work there. If you have more specific questions, feel free to reach out to me and I can address those. Let's see. Yeah, okay, so there's some interest in the evolution history on CI/CD. So that's something I can take a note of. Maybe put that into another presentation or blog post. I've actually personally done a lot of work on the CI/CD automation with Pulsar, so I could talk a lot about that. Let's see, a couple more questions. In which case would you cache between Pulsar clusters, and when simply replicate natively between clusters? That's a tricky question. I'm not an expert on georeplication or replication between clusters. That's something that we've been working on at Overstock. It really depends. I mean, I would say the biggest difference is whether you're using a kind of a pull model or more of a push model. And so, like, if you're dealing with streaming enrichment, having a cache is really nice, especially if you want something that's going to have like microsecond or typically is going to be in the hundreds of microseconds for Redis or Ignite. Of course, it depends on hardware and other factors as well, networking and things. But if you're leveraging Pulsar specifically, then and replication, then it's really more of a push model. So you're moving more into real time rather than where you're pushing that data into your application, rather than having to go back to Ignite and query to get that data. Now, with that said, you could have Ignite somewhere in your path for enrichment. And so streaming enrichment is really useful. And especially for analytics, analysts, the more you can pre-process that data and make it easy to analyze, the more time you're going to save. And sometimes just simple changes can make a huge impact. Oh, we've got questions coming from the live YouTube stream. Okay, so Shujay, thank you for copying and pasting those here. So I'll address those. Just to finish, kind of wrap up this one question. One other approach that you could take is if you leverage Flink. If you have, you could ingest from multiple Pulsar topics at once, including things that have been dereplicated or things like that, if you wanted to, for additional processing. So, feel free to look into Flink. There's some good videos on Flink, but the best way to learn Flink is to just try it out. I found that's, Flink is kind of, I don't want to be too critical in their documentation, but you kind of just have to try it to really wrap your head around what it's doing. and what it's capable of. Yes, okay, so open source UI would be awesome, I agree. Thanks for the comment. Okay, a couple questions from the YouTube live stream. So what is the Pulsar and Flink version we've done with this POC? Oh, let's see. I would have to go back and double check my notes on the Flink version. I took paternity leave, and so it's been a little while since I looked at that. At the time, we were using the most recent version of Flink, and I can't remember exactly the number there. And then Pulsar, we were running 2.4.1, and we're planning to upgrade soon. We've just had some other priorities we need to address. And then also there are some nice features in the more recent versions of Pulsar. Let's see, 2.4.1, I think it was 2.4.0 that may have been incompatible with Flink. Oh, I remember. We needed to upgrade to 2.4.2 or something like that to get the Flink compatibility to work right. So make sure you're using a Pulsar version that's later than 2.4.2. Hopefully I'm remembering that correctly, and if I'm not, then someone should please message me and correct me. Let's see, do you have a dummy application where we can see these concepts working? That's something we could do. I don't have that handy right now. I'd have to get things set up, and most of the work I did on the tracing architecture was before I went on paternity leave, so I'd have to pull some of that up. But that's something that we could do potentially in another presentation. In terms of like looking at some of our production stuff, we have to be careful with like for some of those things, because we have live data, there are some security implications there. So, but yeah, creating a demo application or dummy application, we might be able to do something like that. And then the functions, are they Java based or any performance analysis done? Yeah, so far, I think all the functions in this or in the flow that in the flows that we've talked about were Java based. Let's see, for people who are using other applications, typically they've had those applications living in Docker containers, in like more of the PubSub model. So if we go back to some of those earlier slides, like here, for example, right? We've got containers running producers or consumers. That's typically how other languages have approached that. It's been a little while since we tried deploying Python functions. It's a little different than dealing with Java functions. The main reason why we've used Java so much at Overstock is because we have a lot of infrastructure and automation things built around our Java flows, because Overstock has worked a lot with Java historically. And so I've been looking at how to create a really good CI/CD implementation for Python and for Go functions as well. Let's see, do we have any additional questions? I guess we're a little bit over time.
I think we don't have any other question at this moment.
Okay.
Yeah. Thank you, Devin, for the whole presentation. And if you have any more questions, you can reach out to Devin. Devin, you want to show the slides about your contact again?
Yep.
Yeah. So if you're interested about presentations about Pulsar, you can follow up, subscribe to our YouTube channel. Follow us at Twitter. We would have a regular webinar about Pulsar like every 2 or 3 weeks. Thank you, everyone.
Awesome. Thanks.
Thank you, Devin.
Thank you.